All right, guys. So we're going to begin with chapter 1. As I told you, it's mainly terminologies. And the nice thing about this handout, it has a summary of all the terminologies that you need to memorize for chapter 1. And I'm going to begin with those summaries. I'll do as much as I can today, and then we'll complete the rest tomorrow. All right. So in section 6.1, the first question I ask my students is, what is statistics? And statistics is not just one word. It's the science of collecting. So you collect data, you organize data, you analyze data, and interpret data. The most important part of statistics, guys, is to interpret the data that you collect. So this is a definition of statistics. You might have in the homework questions a question to select, the proper definition of statistics. So you collect data, you organize data in tables and graphs, and then you analyze it. And this is really why you're taking this class, to learn how to analyze and interpret data. What is a population, guys? A population is the collection of all outcomes. For example, all students at Henry Ford College, this is considered a population. Now, if I want to pick a sample will be the students who are taking my statistics class. So a sample is a subset of the population. So I could write here, example, all students at Henry Ford College. For the sample, we can say students taking biology classes. You will be hearing about the population and samples, guys, throughout the 7 weeks. So it's extremely important that you understand the difference and the meaning of each. Again, population is a collection of all outcomes, and the population doesn't have to be big. I could make the population to be all students in my statistics class. And a sample would be, guys, the students who are wearing glasses, for example, that would be a sample. Or female students in my class, that will be a sample. Or male students in my class will be a sample. So the population doesn't have to be like in millions. You define what population. The key word, guys, to know whether you have a population or a sample is when the word all. Once it says all, you can pretty much be sure that it's going to be the population, not the sample. What is data? We keep talking about collecting data. Data is consisting of information coming from observations. So you observe something and you take notes, counts, measurements, or responses. When you give people a survey and they respond to the survey, this is called a response, and this is how we collect data. There is an example of that. People who eat 3 daily servings of whole grains have been shown to reduce their risk of stroke by 37%. So this is a data was collected from people who eat whole grains, and they noticed that those people reduce their risk, of stroke by 37%. So now we learn, guys, what statistics is, what the population is, what the sample is, what data is, and now we're going to learn what the parameter is. A parameter is a number that describes the population. It comes from the population. It's a numerical description of a population characteristic or attribute. For example, let me give you an example here. The average age of all people in the United States. And how would you guys know that this came from a population? Do you remember what I just said 1 minute ago? I said the word all. That should give you a clue that this is a description of the population, not a sample. So I would highlight, just this one right here. Now, what is a statistic? Statistic is different from statistics, guys. Statistics is the class that you are taking, but statistic is a number that summarizes a sample. It comes from a sample characteristic. Let me give you an example. Average age of people from a sample of 3 states. How do we know, guys, that this is a statistic, not a parameter? Would the students be able to answer? If I gave you this one, you know, just in the homework, and I ask you, does this represent a statistic or a parameter? How would you figure this out? Should be easy to figure out. Any responses? You can put it in the chat. Yeah, the word sample, exactly, Yaman. It says it comes from a sample of 3 states. Even if it says from 3 states, I would still say it is a sample because we have 50 states. Since we didn't take all of them, it is a statistic. Okay, let's do this exercise together. Decide whether the numerical value describe a population parameter or a sample statistic. A recent survey of a sample of college career centers. Guys, that's it. That should tell you the whole story. He says a survey of a sample, so you know it's a statistic. Reported that the average starting salary for petroleum engineering majors is $83,121. The $83,121 represents a statistic because it's a sample of college career centers. And this is the key here. So that would be statistic. Okay, let's take number 2. Doesn't have to be parameter, it could be statistic too. Let's see. The 2,182 students who accepted admission offers to Northwestern University in 2009 have an average set score of 1442. How do you guys know that this is a statistic or a parameter? Can someone tell me? Any idea? You can text me. So what do you think? It's a parameter, okay. You can reply to all, you don't have to reply to me, just reply to all so the others can see. But why it is parameter? Because of this word right here, guys, the 2000. Because it says that 2,182, that includes everybody. If this was not there, guys, just 2,182, then someone can say probably this is not all the students, a part of them. But once it says the students who accepted admission offers, that includes everybody. So you are correct, it is a parameter. Okay, next. So now we learned, guys, let me tell you what we learned so far. We learned what the population is, what a sample is, what the data is, what the parameter is, what the statistic is. More definitions to come. How do you distinguish between descriptive statistics and inferential statistics? Descriptive statistics is, as it says here, involves organizing, summarizing, and displaying data using tables, charts, summaries, etc. So this is what descriptive statistics. Inferential statistics, guys, and this is really the important part, involves using a sample to make conclusion about the population. If you can see the figure right there, we use a sample of 3 people, individuals, to make a conclusion about the entire population right here. This is what inferential statistics is. Okay, let's see if there are some examples that we can do. Let's do this example, yeah. Example. Decide which part of the study represents a descriptive branch of statistics. What conclusion might be drawn from the study using inferential statistics? A large sample of men aged 48 was studied for 18 years. For unmarried men, approximately 70% were still alive at age 65. For married men, 90% were alive at age 65. What is a descriptive statistics here? The descriptive statistic is what they're telling us, guys. They're telling us that men who were unmarried, only 70% of them were still alive at age 65. And men who were married, 90% were alive at age 65. So the descriptive statistic is this, what they're describing to us. That's the descriptive statistic. Now, what would be the inferential statistic? What kind of inference, what kind of conclusion you can make out of this? This, they will not give you in the problem. This is, guys, you have to figure out. What do you think a possible inference would be from this study? If you want to make a conclusion, let's see what students are saying here. Yes. Anyone can draw a possible inference out of this descriptive statistics. Oh, Hannah says married men tend to live longer. Exactly, that's the conclusion. I agree. That's the conclusion that you can make. All right, that concludes section 1.1. We're going to go to section 1.2. That's an easy one, guys, very easy. Section 1.2, how to distinguish between qualitative data and quantitative data. Qualitative data, guys, consists of attributes, labels, non-numerical entries. So it's an attribute, it's a description. It doesn't have numbers in it. It doesn't have any numbers that you can crunch. So that's what's qualitative. Quantitative data, guys, means numerical measurements or counts. So actual value is actual numbers. And here are some examples of qualitative data. Your measure, biology, chemistry, business administration, statistics, nursing, etc. This is not a number, this is a quality, so this is a qualitative data. Place of birth, your eye color, brown, hazel, blue, green, etc. Dark brown, these are all qualitative data. Can you guys give me some more examples here? So I left the room, just to put more examples of qualitative data. You can put it in the chat. And reply all, guys, if you can, please. Okay, hair color, that's one. I'll put it there. What else? Okay. Place of residence. The type of measure you put that, it's already there. One more, guys. Okay, sex, race, religion. You see, these are all qualitative. We're not interested in qualitative data. We are interested in quantitative data. Quantitative, your age, that's a number. Weight of a letter, that's another one. Temperature, that's a quantitative. Can you give me some more examples, guys? That shouldn't be hard. Just give me 2 or 3. Height, yes. What else? 2 more. Weight. Okay. A student says bank account. Do you think, guys, bank account is, although it's a number, but is it a number that you can crunch? You can add, subtract, multiply, divide? No. Bank account, guys, is a label. So it is qualitative. Although it has numbers, but the numbers mean nothing in there. So it goes under qualitative data. So I'm going to just put bank account here. What do you guys think of your social security number? You think it is quantitative or qualitative? But the social security number, there's nothing you can do with it. It's just a label to identify you. If it is a label, you don't use it for calculations, then it is a qualitative data. So I'm gonna put that right here, guys. And now somebody says salary. I agree, it is quantitative, so money. Your ID, guys, your college ID is qualitative, because the ID is just a label to identify you, just like your name. So then it's, even it has numbers in it, but the numbers mean nothing there. Okay? So this is the difference between quantitative and the qualitative data. That's something you need. So in section 1.2, guys, I think all of the homework is to give you an example and tell you whether it is a quantitative or a qualitative. All right, I'm going to go to the next part. Levels of measurements. For your information, guys, data has 4 categories, and it's categorized under 4 levels of measurements. And I'm going to go over them, all of them. The first 2 are very weak levels of measurements that we don't much use. And the next 2 will be the important ones. Just one second, let me put the charger. Okay, levels of measurements. This is the first level. This is the weakest level, nominal level of measurements. The nominal level of measurements consists only of qualitative data. And it's categorized using names, labels, or qualities. No mathematical computation can be made at this level. And it's pretty much most of the qualitative data that you guys mentioned to me earlier. So this is what the nominal level, for example, religion. Social security number is nominal, although it says number, but it's not an actual number. Bank account, country, these are all nominal level. Why we're not much interested in that? Because we cannot do math computations with this one. So it's not important, but you need to understand what nominal means. So that's the first level of measurement. The next one, it's a little bit higher, but still weak. Let me show you the next one. Ordinal level of measurements. It is qualitative or quantitative data. Data can be arranged in order. There you go. You can arrange data in order or rank it. But the difference between 2 entries at the ordinal level has no meaning. So can you guys give me an example of qualitative data where we can rank them, put them in order? What can you think of? Age, well, age will not work, because age, the difference has meaning. For example, if I'm 18 and you're 16, the difference between our ages is 2. It has a meaning. Here it says the difference between data entries has no meaning. So that means you cannot subtract. You can subtract age, so that cannot be an ordinal level. Ordinal level, mostly, guys, it has to be qualitative. Can you guys give me something that is qualitative, but we can rank them in order? So the alphabet, height, no. Height and weight cannot be ordinal. Let me tell you what. If I'm 160 pounds and another one is 150, I can say the difference is 10 and it makes sense. Remember, here the difference doesn't make any sense at this level. I'm going to give you an example here. Measure, you cannot, yeah, once you said measure difficulty, then you're ranking here. I'll give you an example. Letter grade. What do you guys think? You agree that letter grade is is ordinal because the first, the highest grade is A, B, C, D, E, etc. So this is an example of an ordinal level of measurement. Or any qualitative data that has been ranked, guys. Like a student says, measure difficulty. So you rank them at the top difficult, the first top difficult, the second, third, etc. Then it will become ordinal. So it's mostly qualitative data that can be ranked. But for example, if I say the eye color, that's not ordinal, because who says that brown has to become before black, has to come before green, blue, etc. Or if someone says religion, who says that this is the first religion, the second, the third? They're not ranked. As long as you can rank, then the data will be ordinal. Let me give you this example, guys, and show you the difference between ordinal and nominal. Two data sets are shown. Which data set consists of data at the nominal level? Which data set consists of data at the ordinal level? So guys, can you help me answer the question? For the first one, what do you think it's going to be? Ordinal or nominal? Ordinal, I agree. Do you see why ordinal, guys? Because this is ranked. This is network affiliates in Pittsburgh, Pennsylvania. This is just a list, just of networks, TV stations. They're not ranked. It doesn't tell us that this is top one and the second top or the third top. So that will be nominal, guys. Okay. Number 3. Please pay attention to this one and see if one student can figure this. Give me an example pertaining to this one. Just finish this and we'll be done. One second. For some reason. All right. Number 3. Interval level of measurement. It's a quantitative. It's numbers, guys. No attributes. Data can be ordered. You can order the data, put them, just rank them. Difference between data entries is meaningful. So if you subtract 2 values at this level, it has a meaning. But the 0 represents a position on a scale. So the 0 at this level means something. It doesn't mean nothing. For example, if I tell you I have 0 money in my pocket, that means I have no money at all. But here at this level, the 0 means something. What kind of example you can think of, guys, for interval level of measurement? So think of something that is quantitative, where data can be ordered, where the difference has a meaning, and the 0 means something. What would you think of? Okay, number of kids I hear from, well, if you have 0 kids, that means you have no kids. So 0 means nothing. That wouldn't work. Whether, what do you mean by whether? Elaborate. Oh, temperature. Yes, this is the one. Temperature. That's the most common and important example. And let me tell you why temperature works. Yes. If the temperature today in Detroit is 80 and 78 in Livonia, the difference is 2 degrees, it makes sense. And if the temperature is 0, it doesn't mean that we don't have temperature, we don't have a cold weather or warm weather, etc. 0, it's better than -10, guys. So 0 means something when it comes to temperature. So temperature is the one, and the 0 represents, a position on the scale, because temperature can go above 0 and can go below 0. So temperature will be an excellent example to represent the interval level of measurement. I'm going to give you another example, guys, probably you haven't thought about. It's the year we are in. Like we're in year 2020. You know, there was time where there was a year zero before Christ and after Christ. This is when we started doing, you know, the Gregorian years. So at the time, you know, just right before Christ and after Christ, you know, there was a transitional period, which is the year zero, and it means something. There was something, there were people at that time, there was life. So year is another example, but I would like you to focus on temperature as the most common example for the interval level of measurement. Now, let me ask you this question, guys. Number of votes wouldn't work, because if the number of votes is 0, 0 means nothing. If the 0 means nothing, guys, that means it cannot be an interval. It has to mean something. Okay. Let me give you this example and tell me if it makes sense. If the temperature, let's say in the winter time in Detroit, is 2 degrees Fahrenheit, and in Dearborn it is 4 degrees Fahrenheit, can you say that the temperature in Dearborn is twice as warm as the one in Detroit? Because 4 is twice of 2. Can we make this statement? Does it make sense? What do you guys think? Actually, guys, it doesn't make sense. Let me tell you why. If it is 2 degrees in Detroit and 4 degrees in Dearborn, you're not going to be able to tell the difference. It's going to be very cold. So if it is a 1 degree in Detroit and 2 degrees in Dearborn, it doesn't mean, you know, just that it is twice as warm. You guys, you will not be able to tell the difference between the two temperatures. They're both labeled as cold temperatures. So that means you cannot use ratios at the interval level. You cannot say that if it is like, let's say 100 degrees in Las Vegas and 50 degrees in Detroit, you cannot say that Las Vegas is twice as warm as Detroit, because 50 is cold and 100 is very, very hot. You cannot compare the two this way. So we don't compare this way at the interval level, and in particular when it comes to temperature. And that takes us to the last one, which is the ratio level of measurement. That's the one that you guys, most of your data is going to come from. And let me show you what ratio level. Ratio level is similar to the interval. Data can be ordered. Difference between data entries has meaning, but the 0 means nothing at the ratio level. And one data value can be expressed as a multiple of the other. Unlike the interval, we cannot say that 2 is twice as warm as 1, but with the ratio level, we can say that. And examples, guys, there are tons of examples. Height, weight, money, you name it. There are, most of the examples are gonna fill under the ratio. Let me tell you why, for example, weight works very well at the ratio level. Weight of 0, guys, means nothing. 0 pounds means 0 pounds. There is nothing. Like if a person's weight is 150 pounds and another person's weight is 75 pounds, you can say that the 150 pounds is twice as heavy as the 75. So it does make sense to say that. The difference has meaning. If someone is 150 pounds and another person is 170, the difference is 20 pounds. It has perfect meaning. And 0 pounds means 0 pounds, means nothing, unlike the temperature where 0 means something. So this is an example of the ratio. Age is also ratio. For example, if someone is 18, another one is 9, you can say that the 18 years old is twice as old as the 9 years old. So it does make sense. Let me give you those two examples, guys, and tell me which is which. Two data sets are shown. Which data set consists of data at the interval level and which data set consists of data at the ratio level? We already talked about the year, guys, and we decided that the year is what labeled as what? Interval. And now let's look at this. It's home run totals by team. Home runs is just actual numbers. They can be as low as 0. So these are just ratio level. Any questions about the difference between ratio and interval? Okay, just a summary, guys, and we'll be done for the 4 levels of measurement. Look, nice summary. Nominal, you can categorize data, it's qualitative. Arrange in order, no. Subtract has no meaning. Determine if one value is a multiple of the other has no meaning here because it's all qualitative. Ordinal, it's the same as nominal, but the only difference is you can rank data. So it's a yes here, but the rest are no. And categorized as qualitative or quantitative, but it's mostly qualitative. Interval, guys. It's a quantitative data, so it's yes, you can put it in category as quantitative. You can arrange it in order. You can subtract, but compare one temperature with another as a multiple of the other has no meaning, so it's a no. You see the ratio, it's all 4 yeses. That's why I told you it's the most important one. So it's yes, 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 yes. Okay, we're done with sections 1.1 and 1.2. Tomorrow, I just need about 10-15 minutes to finish section 1.3. You can start doing the homework of 1.1 and 1.2 right away after you log in. And